In this video, we're going to talk about even and odd functions. So not necessarily even and odd degree polynomials, but even and odd functions as far as when the graph is going to be symmetric in respect to the y-axis or the origin. So our even function is represented by f of negative x equals f of x. So regardless of whether x is positive or negative, you get the same output. So most basic example is just a parabola here, y equals x squared. Whether x is a positive 3 or negative 3, we're still going to get a positive 9 as our output. So this is symmetric with respect to y-axis. So that's how we can think of it as far as the graph. And then equation, you have to think of your output being equal in regards to that. So for an odd function, f of negative x is equal to a negative f of x. And on the graph, it's symmetric with respect to the origin. So it doesn't exactly mirror the same way we think about reflecting across the x or y axis. It's more of a 180-degree rotation. So one way to look at it is whatever output you get with your input, if you flip the sign of both of those, so in this case we've got 2 comma 8, down here it's going to be negative 2 comma negative 8. So we're just going to change the signs of our x and y value. So we've got a couple examples here. We want to determine if they're even, odd, or neither. Well, this one here, it goes through the origin, so that's kind of the first thing I'm looking for. It's not reflected across the x or y axis, so I'm not looking at even. But if I were to take this curve here and I rotate it along the origin, it looks the same exact here. So this would end up being odd. Oof, that's great. For B, we have it these curves mirrored exactly across our y-axis. So that one would be even. And then this one here, well, if we take part B and we we reflect across the y-axis here, it's mirrored exactly. And we see the same thing here when our if we've got an axis going right through the middle, like here. But because this isn't where the y-axis is, it's not reflected across the y-axis, so it's not an even function. So this one would end up being neither even nor odd. This example here, we want to just complete this graph of f of x so that it gives us an even function. So I know even function reflects across the y-axis. I'm going to duplicate this and flip it across so that we have it mirrored on the left side. And there's your even function. For making this an odd function, we again have to duplicate it. We're not reflecting it down across the x-axis. That doesn't give us anything really. But we are going to rotate this 180 degrees coming from the origin. So this would give us an even function. As far as the table goes, we'll go back to even function. And I always think of a parabola as far as how I need to match up my output, my y values for f of x. Well, if negative 9 gives us an output of 5, then positive 9 should also give us a 5. For 6 gives us an output of 4, so negative 6 should also give us a 4. And then negative 3 gives us negative 2, so positive 3 should also give us a negative 2. Right? And then we go through the origin 0, 0, which we need for both an even and odd function. If we want to make this an odd function, again, we're going through 0, 0, so it's a good start. But if x is negative 9, and that gives us an output of positive 5, then we flip both signs. So positive 9 gives us negative 5. Positive 6 gives us positive 4. So negative 6, we should have a negative 4. And if negative 3 gives us negative 2, then a positive 3 would give us positive 2. Okay. Again, looking at some basic examples here for even function. If we're just evaluating an equation, being even or odd, well, x squared, whatever that gives us for an output, if we are now inputting a negative x, we square that number, and that's going to give us the same output as what we got for f of positive x. Because squaring a negative value is going to give us a positive value. For an odd function, the most basic example there is x cubed. And if we think about inputting a negative x value in there, when we cube a negative value, it'll give us a negative. And so that matches with this here. So looking at some specific examples, because it's not going to be as straightforward as x squared or x cubed as our function. In this case, we've got minus 6x at the end of our cubic function. So if we look at how that actually affects our graph, it is still going through the origin and it looks symmetric in respect to the origin. So this is still going to give us an an odd function, not just an odd degree polynomial. Now, if this said minus 6, not minus 6x, it's going to take our cubic function and it's going to shift it down 6, and it won't be through the origin anymore, and it will no longer be an odd function. But in this case, it is still odd. For this one here, we have x to the 4th, so it may be an even degree. So let's take a look at what the minus 3x squared does. And it still is going through the origin, and it's symmetric across our y-axis. So this one's still even. So notice how if we add or subtract some other term in our polynomial that isn't a constant, it's still giving us functions that are even or odd based on that leading exponent, or our largest degree in our polynomial. In this case, x to the 5th would be odd all on its own, but if we add that plus 1 in there, it shifts the whole thing up 1, and now it no longer goes through the origin, so it is no longer an odd function.